This is our final FEDD presentation by Daugherty, Brian Hegarty, Jack Wasserman, and Chance for the bubble. Our design process began with writing and drawing different designs for our bubble machine, which ranged from having wands that spun through solution all the way to a bubble gun. Needless to say, the last one was a bit ambitious, so it's better that we chose a more simple design to keep our project on track and actually working. Building the casing for our bubble machine was simple, so where we spent most of our time was with angling the bubble wands as well as the trough, because what we had a big problem with was when the wands would spin, they would get caught on the side of the trough and they would actually stop the motor from working, which was detrimental to the machine. Even after the final adjustments were made, we tested the machine a couple more times just to make sure that our final project hadn't been a fluke and it worked and still blew bubbles.
In the picture that is shown, we are roughly halfway through with building the wooden box that houses our motor. As you can see, Chance is securing the platform that holds the motor with multiple screws. The only problems we ran into while completing this process was that we cut the platform slightly too short, so we had to wedge in small pieces of wood to make it stable.
The picture shown took place during the final modifications of our project. Brian is adjusting the wands so that the fans could blow the bubbles properly. This was important because when the wands are not in the right position, the bubbles won't detach and we end up with a mess of solution everywhere.
In this picture here, Chance is removing the 3D printing that was in the recycled canoe. After this, we had to use hot glue to completely seal the bottom of the canoe to avoid any leaks. This canoe ended up being a perfect size for our bubble machine.
Some of the challenges that we faced while making our bubble machine were finding a bubble solution that worked for the speed of our fan and motor, as the solution had to be stronger, which is why we added more corn syrup than we anticipated. The motor itself also caused problems as it rotated faster than we expected and caused us to change fan angles and speeds to counter this. The last challenge lied in finding a trough that was shaped properly so that the wands didn't hit it and end up harming the motor.
In this year's 16th Fed Day competition, we scored in a place that was honorable mention. Now, we scored in this place due to our recycled materials and the fact that we used a concrete canoe mold as our trough for our bubble solution, as well as our bubble wands that were actually shower rings that had been wrapped in pipe cleaners, which hadn't been seen before in the competition.
If we could do the project over, we all agreed we would make a smaller bubble machine so it would be possible to meet the voltage requirements. Also, we would have began testing earlier, and that would have allowed us to put more time into making our machine more aesthetically pleasing. We would have tried a few more fan angles and speeds to make the best bubbles possible. If we would have started earlier, we could have made our design more creative. We could even have tried to make and test many different designs. We even thought about creating a bubble gun, and that design would have been really cool, but I'm not sure if we could have done it with the time that we allowed ourselves to actually test, so we should have started earlier.
One of the biggest pieces of advice I could give to new groups having the bubble machine is to pay attention to the 6 volts right out of the gate, because we didn't pay such close attention to it, so we operated on a much larger scale than we should have. And then when we paid more attention to it later down the line, we couldn't exactly adjust the scale because we had already built the machine with the larger bubbles in mind, so we couldn't exactly just have less powerful fans to produce the same results. More advice I have is to make sure that to make it as unique as possible, because a lot of the designs I saw at FEDD were all the same with the rotational device to try and pick up bubbles before they detach from the machine. Some advice about FEDD in general would be not to procrastinate, because the later you start, the less time you have to adjust to any potential problems that may start. And it's also a really good idea to test early, because like I just said, the less time that you have to test means that you're going to get less accurate results, and you're not going to be able to make the project as good as it could be. And also, you should spend a majority of your time planning the design so that you can minimize the amount of time you have to spend actually fixing things, and you can get it right the first time. And finally, I would say that you should follow your timeline pretty accurately, so then you're not rushed. And also, remember